Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we will introduce a new decision statement. The if, else statement and the conditional operator are both great. They work best when there's only a handful of things to evaluate. But if you start needing to evaluate many different potential cases, you might find that the switch statement is a little bit more concise and keeps things a little tidier. And that would probably be one of the only reasons why you would use it, and I'll show you a second reason why in this video as well. So we'll come back to the switch in just a little bit, but first I want to talk about a special data type called an enum, or an enumeration. Typically, we want to limit the possible values of a given variable. Now, admittedly, we're already limiting the possible values that can go into a variable by virtue of the fact that we've given it a specific data type. However, even within that, I may want to limit the number of possible values to just a handful. So typically in software development, you want to limit and constrain your data to ensure its validity inside of your system. An enumeration is a data type that limits and constrains all possible values to only those that are valid and have meaning within our system. So, for example, we might want to keep track of a series of to-do items. Maybe that's the type of application we're building. And each to-do item is represented by an instance of a to-do class. And so we may want to keep track of the current status of a given to-do item on our list. And so we may want to constrain the possible statuses to maybe like 5. That the task has not been started yet, or it's in progress, or it's on hold, it's been completed, or perhaps it's been deleted. There might be some other statuses, but you can see how I may want to just limit the number of options that are available for a status field or status property of my to-do class. So we could do this a number of different ways. We could just concoct a numbering scheme where 1 is always represents not started and 2 represents in progress. But numbers are, I refer to those as magic numbers. They may have some meaning in the system, but it's not readily obvious if you're reading the source code. You know, as the developer, you may have to look up at some external reference, maybe some code comments, and who knows, maybe those aren't even, maybe they're not even current anymore. Maybe things have changed since whoever wrote those code comments originally wrote them. So I may need to reference or look through a number of different code to ensure that what number 1 means in the system, what number 2 means in the system, and so on. The same thing can be true with strings. I could just use a literal string to indicate the current status. So I could use a literal string, not started, or in progress. But the problem with literal strings is that somebody can mistype them, or they could be there could be a space and not started one time, and then somebody uses not started without a space the other time. And so they may not, if you're looking for all those items that have not been started yet, you may have a hard time finding those that have not yet been started or are in progress because they're not spelled correctly or whatever the case might be. So the great thing about an enumeration is that it gives us a textual equivalent to a numeric value so that it'll remove any ambiguity inside of the system. As developers, we know exactly what we're working with, and yet behind the scenes it's still working with a number. And enumerations are used frequently in the .NET Framework class library for the very same reasons. So for example, you can see here that I have a project, enums and switch, and here again, if you look in the code folder for this lesson, there should be a before and after. You want to copy the enums and switch project from the before folder and copy it into your projects directory so that you can catch up to me where I'm at this moment. You can always pause the video and type all this in if you like. It'd be quite a bit of typing though. You can see that in this project I've already created a to-do class with a description of each to-do item. the estimated number of hours it should take to complete the to-do item. And then notice that I have a status of type status. Where does this come from? Well, you can see directly below I've created an enumeration called status. And I have not started, in progress, on hold, completed, and deleted. Did you notice as I hover my mouse cursor over it that each of these values are given a numeric value? So not started equals 0, in progress equals 1, on hold equals 2, and so on. If we were to store these values somehow in a database or a text file, those are the values that might actually get stored. However, they will be translated into this more textual format so that when we're actually working with the data, as you can see here in the static void main, as we're creating a new list of to-dos using the collection initializer syntax, here I'm setting the status equal to either completed or in progress or deleted or not started and so on. And visually, it's much easier for a developer to work with those options in a more textual sort of way. Now, the .NET Framework class library will use enumerations extensively. In fact, even in the console window, if we were to set the foreground color, notice that IntelliSense automatically pops up to the console color enumeration. See, it says enum over there. Whoops, let's see. I don't think you can see that. Let's go up a little bit here. All right, there. Okay, so now you can see the word enum right here. It's console color enumeration, and when I hit the member access operator, the period, it will show me all the colors that we can choose for the foreground color of our console window. So I might choose dark red. Okay, so again, enumerations are great because they are descriptive and they limit the number of possible values for our applications, for the properties of our classes. All right, the next thing I want to talk about is the switch statement, and these two are going to marry together here in just a moment. But a simple switch statement is going to look something like this. In fact, I'm just going to go switch tab tab, and that will create essentially the outline for it. And in this case, we could do something like we can use an individual to-do item and choose its, let's say estimated hours. And so if the estimated hours are, for example, case 4, all right, then we might perform some operation until we hit the break statement. Or we could go case 5, so we could perform something and then we would hit the break statement and break out. There's also a default case that would be the catch-all, just like the else statement in the if, else construct. But the most important aspect of this is the construct of the switch statement. You have the keyword switch, then you have a value, a variable that's under evaluation, and then a series of cases where we would try to match it up with one of these cases, and then we use the colon after that case. We write our code below it, and then we use a break statement to break out and continue on our execution of the code. Now we might choose to, for example, do something like this. This makes a little bit more sense to work with the statuses. So in this case, we might go status dot completed. We might do something versus case status dot deleted, and we might perform some operation there, and so on. Now, the beauty of the switch statement and the enumerations are that they kind of can conspire together here. So watch what I do. I'm going to type switch tab tab, and then I'm going to go to do, which is each of the items in the to do collection, dot status, and then I'm going to hit the enter key on my keyboard twice. And the second time I hit enter, see the macro that will actually blow out each of the individual statuses so that I can write code associated with each status. All right? Isn't that crazy? And so now I can do here anything that my business logic would require. I have an idea though. Let's use the foreground color and change it up for each of the individual to-do items. So it can be as simple as this. Let's just copy this and we'll put it here for each of these statuses. And then here at the very end, we will actually then do a console.writeLine of the actual item itself, the to-do description. And here we'll change up the color. So if it's not started, we'll leave it as dark red. If it's in progress, we'll use green. If it's on hold, maybe we'll use, the dark red. Let's use the red here and the dark red there. Completed, let's mark those as blue. And if it's been deleted, we'll mark that with yellow. Okay. All right, so now let's go ahead and save and run our application. And you can see we have a very colorful list of tasks that are color-coded by their current status. All right, see how cool that is? All right, so in this lesson we talked about enumerations and why we would use an enumeration to constrain the possible values for a given property of our classes. And we saw how it was used in the .NET Framework class library, one little instance of it here, where they've created their own enumerations. Just be aware of, as you're trying to work with a given class and its properties, always look at, for example, in this case, what data type it is. So this is a data type console color, and typically IntelliSense will point you kind of in the right direction. As you hit the equal sign, it will pop down to that data type, that enumeration, so that you can just hit the period and then you can make your selections there. So that's a really good hint. And then we looked at the switch statement, the structure of the switch statement, where we're evaluating something in between the opening and closing parentheses. We looked at the body, the opening and closing curly braces, the entire body of the switch statement, and then inside the creation of a number of cases, each case equating to one possible value of the item that's being evaluated, and then a colon, and after that, then any of the code that we want to write, and finally a break line which will pop us out of that switch statement's body. And then finally we saw that there is a catch-all, the default colon, which we can use to write any code for cases that we haven't accounted for in any of the other previous cases. Okay. All right, so that wraps up this lesson. Doing great. We're getting close to the end now. You feel pretty confident in C#. You've got the majority of it under your belt. Just a few more topics we want to cover, and then we'll wrap this up. We'll see you in the next lesson. Thank you.